Hi, this is Algebra 2, Lesson 21. We're going to talk about scientific notation and two statements of equality. We're starting on page 101. When we multiply a number by a power of 10, the decimal place moves to the left or right according to the power. Multiplying by a positive number of 10 moves the decimal place that many places to the right. Multiplying by a negative power of 10 moves the decimal place that many places to the left. So, if we have 412.036 and we multiply it by 10 to the power of 2, that means we're going to move the decimal 2 places to the left. To the right. Sorry. So that'll be 41203.6. If we have 412.036 times 10 to the negative 4th, we're going to move the decimal 4 places to the left. 1, 2, 3, 4. So we have 0.0412036. This is very useful when we're dealing with very large or very small numbers. So now we have 304.162, and we can rewrite this a couple of different ways. We can move the decimal 3 places to the left, 1, 2, 3, and have 0.304162 times 10 to the negative 3. Or we could start here at the beginning and move the decimal 3 places to the right, 1, 2, 3, and we'd have 304.162 times 10 to the third. You'll notice that in both cases, the power is telling us where the decimal was before we started. If it says negative 3, that's telling us that now the decimal is here, but originally it was here. Here it says to the positive 3, and that means it was originally here. Okay? So the positive 3 or the negative 3 tells us where the decimal is supposed to be when the number is written in its original state. The standard form of scientific notation puts the decimal after the first non-zero digit. So here we are again with 304.162. And to put this into standard form, we're going to move the decimal just to the right of the first non-zero digit, which in this case is this 3. So we would have 3.04162, and we moved it 2 places to the left. Okay? So this is this number in standard notation, in standard scientific notation form. So now we have 0.0412036, and we're going to put this into standard scientific notation form. So we need to find the first non-zero digit, which would be this 4. We're going to move this decimal 2 places to the right. So we have 4.12036 times 10 to the 2, because we moved it 2 places to the left. So it'll be positive 2. Here's our first problem. Simplify this mess here. We're going to start by putting all of the numbers into scientific notation. So here we have 0.0003 times 10 to the negative 6, and we're going to put it in standard form, so we're going to be moving the decimal 1, 2, 3, 4 more places to the right. So it'll be 3 times 10 to the negative 10. It was negative 6, we moved it 4 more places to the right, so now it's negative 10. Here we have 4,000. To put this into scientific notation, we're going to move the decimal 4 places to the left. So it's 3 places to the left. 10 to the third. Over. Here we have 0.006 times 10 to the 15th. We're going to move the decimal 3 places this way. So this will be 6 times 10. This would be negative 3. So 15 minus 2 minus 3 is 12, negative 12. Oh, sorry, positive 12. And here we have 2,000 times 10 to the 4th. We're going to move the decimal 3 places this way. So we'll have 2 times 10 to the 7th. So we moved it 3 places plus 4. Now I can multiply the digits and add the powers in the denominator and the numerator. So we can do 3 times 4, and we have 10 to the 10th and 10 to the 3rd. And on the bottom we have 6 times 2, and we have 10 to the 12th and 10 to the 7th. Okay, so on the top here we have 12 times, we have the same base number and they have different exponents. We're going to add the exponents together. So negative 10 plus 3 is going to be negative 7. So that's 12 times 10 to the negative 7th. And here we have 12 times 10 to the, we have to the 12 and to the 7th, so that's to the 19th. Okay? The 12s cancel, so we're left with a 1. If we move this up, remember this becomes 10 to the negative 19th when we move it up to the top. So this is going to be 1 times negative 7 minus 19, which is negative 26. And that's going to be your answer. So that was pretty much review. We did that last year. We've done it before. Now we're going to talk about two statements of equality. We're going to be working with different kinds of word problems that contain two statements of equality. We will solve them in similar ways to the value problems we've already been doing. So we have the ratio of two numbers is 3 to 4, and their sum is 84. What are their numbers? So first of all, we need to remember that a ratio is just a fraction. So a ratio of two numbers is 3 to 4. That means their ratio, so we have number 1 and number 2, and their ratio is 3 to 4. Okay? We also know that their sum is 84. So n1 plus n2 equals 84. Okay, we can cross multiply this first problem. Let's call this problem A and this one B, just so it's easier to talk about them. So we can cross multiply A and then solve for either of the variables. So let's solve it for n2, and then we can substitute that into this problem. So we have 3 times n2 equals 4 times n1. If we solve for n2, we're going to divide both sides by 3, and n2 equals 4 thirds n1. Okay, we can substitute this into this problem for n2 and then solve for n1. So we have n1 plus 4 thirds n1 equals 84. This is 1 n1, so this is 3 thirds. So 3 thirds plus 4 thirds is 7 thirds. We have 7 thirds n1 equals 84. We can multiply times the reciprocal to get rid of this fraction. And we have n1 equals 84 times 3 divided by 7. Which equals 36. Okay, if n1 equals 36, then we can substitute that into both of these problems and check for the check. So we have n1 plus n2, sorry, this is 36. 36 plus n2 equals 84. I did not leave myself enough space. And 36 over n2 equals 3 over 4. Okay. subtract 36 from both sides here. We get n2 equals 48. If we solve this over here, we get 4 times 36, which is 144, equals 3 times n2, divided by 3. And n2 equals 48. Okay, let's try another one. The sum of two numbers is 124, and their difference is 44. What are the numbers? Okay, so we have the sum of two numbers is 124. So n1 plus n2 equals 128, and their difference is 44. So n1 minus n2 equals 44. So let's solve this problem for n1, just to be different. So if we add n2 to both sides, we'll have n1 equals 44 plus n2. And now we can substitute this into the first problem for n1 and solve for n2. So we have 44 plus n2 equals 128. Subtract 44 from both sides. We have 84, and we have n2 plus n2, so 2 n2s equals 84. Divide by 2, and n2 equals 42. Now we can substitute this into both of these problems, and hopefully we'll come out with the same value for n1. So we have n1 plus 42 equals 128, and n1 minus 42 equals 44. Subtract 42 from this side, and n1 equals 86, and add 42 to this side, and n1 equals 86. There you go. When you do these problems, I want you to show your work and circle the answers. Here's n1 equals 36 there. That way I can find it. Okay? That is it for this lesson. Try the practice problems and let me know if you have any questions. Thank you.